Okay, so today we're going to be working on assignment 4. It is about real numbers. Okay, so you have this little note sheet. Okay, please keep it. You're going to need it. So all numbers are real numbers. Okay, once you get the hang of the chart, it's super easy. Okay, all numbers are real numbers. So it does not matter if you're talking about pi or 24 or 1/2. Okay, all numbers, or -14. All numbers are real numbers. Okay, the same exact way money's money. Would you agree? It doesn't matter if you have $5 in quarters or you have a $5 bill. Okay, it doesn't matter if you have 500 pennies or $500. Okay, it's still money. Okay, obviously I don't want 500 pennies, right? I would prefer the bills, but it's still money. Okay, now there are really two types of money. You have cash and you have change. Would you agree? Okay, the same works with numbers. Okay, we have rational numbers and irrational numbers. The majority of numbers are going to be rational numbers. Okay, within rational numbers falls integers, whole numbers, natural numbers. Okay, the same way that there is lots of change. Okay, and so when we start to look at this, and we'll go through it, and by the end of today, you should be good about getting and understanding the chart. Okay, I always had a hard time with this, even when I was in college, and then one day it clicked. Okay, and now I'm like, oh my gosh, that makes sense. Okay, so rational numbers, there are 3 types. Okay, the very first type is going to be a repeating decimal. Okay, a repeating decimal looks something like, maybe it could be 8.333, okay, or some people label it like this, 8.3 with a line above it. What that's saying is after the decimal point, the number stays the same. It's 0.3333333, and it keeps going on forever. Okay, it could be 0.1111111. Okay, another type of rational number is a terminating decimal. Okay, so a terminating decimal is going to look like this, like 8.5, okay, or maybe 50 cents, okay? 50 cents is a terminating decimal. Okay, and then the last one, it's still a terminating decimal, but I always like to write it, would be a fraction. Okay, a fraction is technically 1/2 is 0.5, okay? But that is where, if you see it as a fraction, then it makes so much more sense, okay? So those are the 3 types of rational numbers, okay? Repeating decimal, terminating decimal, and a fraction. While we're just talking about it, the only difference for a rational to an irrational is the decimal, okay? So an irrational number, the decimal, I don't even know how to say it, but the numbers keep changing. Okay, so what that means, if we look at pi, and I don't know what the numbers are, but it's 3.14, and then maybe it's like 8, 9, 4, 2, 1, 2, 3, 6, 7, 8, 9, 1, 2, 0, 2, 3. See how after the decimal, they just keep changing. It never ends, and it keeps changing. That's what makes it a irrational number. So these ones, even if it keeps going, it's still a 3 constantly, okay? This just keeps changing, and it goes on forever and ever, and it doesn't stop, and it just keeps changing. And so that's what makes it irrational. Okay? There are integers. Integers are going to be anything positive or negative, okay, or 0. So these are going to be positive, negative, and 0. Okay, whole numbers are just 0 and positives, and naturals are just positives. So today I'm going to constantly say, well, start on the inside of the chart. Okay, I know some of you guys are like, I am freaking lost. That's okay. Okay, constantly I'm going to say, start on the inside of the chart. See how there's a big box, and then it goes little, and then little, and then little? Okay, well, the reason we start on the inside of the chart you can see that positive fits all of these. Okay, these are, if we look up here, rationals are positive, negative, 0, and we say other. Okay, we know that naturals are just positive, wholes are positive and 0. This is positive, negative, and 0. Okay, and so it just keeps building on. Okay, so if we look at, and I say number 3, okay, is 3 a natural? Yes. Okay, is 3 a whole? Yes. And 3 is also an integer. So at the point in time when we say yes, everything above it is a yes. Okay, so you would list, yes, it's a natural, yes, it's a whole, yes, it's an integer, yes, it's rational. Okay, look at 0. Is 0 a natural? No. Okay, is it a whole? Yes. Okay, then it is also an integer, it is also rational. Okay, as soon as we enter yes, everything above it is a yes. Always start on the inside of that box. Okay, if you have negative 3, is that a natural? No. Okay, is it a whole? Negative 3? No. Okay, because it's a negative, it's not a positive or a 0. Is it an integer? Yes, and then yes. Okay, so yes, it's an integer, yes, it's rational. Okay, what about 0.5? Is it a natural? No. Okay, is it a whole? No. Integer? No. Rational? Yes. Okay, what about the number 7? Okay, is 7 a natural? Yes, because it's positive. Okay, is it a whole? Yes, yes, yes. Okay, as soon as we answer yes, everything above it's a yes. Okay, the best you're going to get is just with practice. Okay, that's why I'm like, go through 550 examples. What about the number 200? Okay, is it a natural? Yes, it is. It's a positive number. Okay, so yes, so that means yes, it's whole, yes, it's an integer, yes, it's rational. As soon as we say yes, everything above it is a yes. Okay, and I will really come through today and like work with you on some of these numbers, okay? So look at the sheet that I actually gave you today, okay? Write your number on the front. You'll be able to tell the front because it's got a 4 on the very top, okay? Okay, so instead of writing these all out, I often do this, okay? You can if you want to, but make sure you're using the right letters, okay? Instead of spelling out the word rational, okay, I put R. Okay, irrational, we have to say IR. In integer, we say I. A whole, I say W. And a natural, I say N. Okay, you can write it out if you want to. That's a lot of writing. Okay, because some of these are going to have all 4. Okay, 1/2. 1/2. And we start on the inside of the chart. Okay, is 1/2 a natural? No, it's not. Is it a whole? Is it an integer? Is it a rational? Yes, it is. So when we go, and it can only be rational or irrational. So you never need to look at this chart, really. I mean, you do for some of the numbers, but we know that 1/2 is just rational. Okay, so you're just going to put R. Okay, and I'm going to do every other one. Okay, look at number 3. Okay, the number we're given is -4. Is -4 a natural? No. Is it a whole? No. Is it an integer? Yes. Yes, and so the one above it, which is what? Rational, is also a yes. So you're going to put it's an integer and it's rational. Okay, make sure you use a comma because if you put the IR right next to each other, what am I going to think it is? Irrational. Irrational, okay? So make sure that you use that comma, space them out nice and good. Okay, look at 5. The number we're given is 0. And look up here so you know what's going on. Is it a natural? Yes. No. Okay, it's not a natural. Is it a whole? Yes. Yes, 0 is on our list. Okay, that consists of product. So if this is a yes, what's the one above it got to be? Yes. Yes and yes. Okay, so yes, it's a whole. Yes, it's an integer. Yes, it's rational. Okay, look at 7. The number we're given is a 1. Okay, it's a positive 1. Is 1 a natural? Yes. Yes, it is. Okay, so everything above it is a yes. Okay, so it's going to be yes, it's a natural, it's a whole, it's an integer, and it's a rational number. Okay, it consists of all 4 numbers. Number 9, the number we're given is 8. Okay, is 8 a natural? Yes, it is. Okay, it's just a positive number. Naturals are positives, so that means everything above it is a yes. Okay, so yes, it's a natural, it's a whole, it's an integer, it's a rational number. Okay, if you put everything on here except for an integer, is that correct? No, it's not. It is also an integer. It has to be. Okay, so make sure that you're including everything that should be included on there. Okay, look at your next page. Okay, the last one, it just wants you to list, and I'm going to do the top 3, and you guys do the bottom 3. Write an example from daily life that uses each type of real number. Remember, all numbers are real numbers. Okay, so we have a whole number. What are whole numbers? Look at your sheet. Are they positive, negative, zeros, what?
0 and positive.
0 and positive. Now, I want you to think about your life. Okay, and some of you guys will think way too hard, even if you just look around your desk, right? What do you have 1 of or 2 of? Okay? Do you all have 1 pencil? Yeah, that qualifies, so 1 pencil. That is an actual example from your daily life that qualifies as a whole number, right? You have 1 pencil. It's a positive number. You have 1 of something. Okay, what about an integer? What are integers? Negative, positives, and 0. So what is something in your life that is either negative, positive, or 0? Look around on your desk. What do you have? Okay, I see you have headphones, right? You have 1 pair of headphones. Is that a positive number? 1? Yeah, so that counts. Okay. Oh. Start writing wrong. Okay, rational. Where do we use rational numbers in the real world?
Cutting a cake.
Cutting a cake, yeah. Okay, cutting a pizza. Why?
Because it's a fraction.
Because it's a fraction. Okay, where else do you use fractions? Maybe you guys don't, but like when you cook, right? So I make freaking Kraft macaroni and cheese 500 times a week. Okay, I'll tell you right now, it takes 1/4 of a cup of milk. Okay, so that is a fraction. Okay, so you could say that